Okay, I'd like to do an example for you that's very common in algebra course, which is the class that I originally wrote this for. We'll do these kinds of problems in the first assignment, or at least as part of the first assignment. In pre-calc, it's, of course, we're going to do circles first. But regardless, you've all seen these kinds of problems before, or should have. So 18x minus 5 equals 4. I would just immediately go to 18x equals 9. What am I doing? The 5, remember, if a term on the left side of the equation, if you move that term to the right side, it changes sign. So 18x minus 5 equals 4 is equivalent to 18x equals 4 plus 5. And the 4 plus 5 was just such an easy sum that I just wrote down that result. You could write 4 plus 5, that's fine. But you should have 18x equals 4 plus 5 or 18x equals 9. Okay, and then I just cross-multiplied with the 18. The 18 just goes from here, it goes down to the denominator of the 9. And 9 over 18 is just 1/2. So again, the numbers were just so simple that I just wrote 1/2 to make it shorter. But of course, if the numbers are more complicated, I would write out like 9 over 18 or whatever the numbers were. Same thing with this adding this thing here. If they were more complicated numbers that I didn't want to do in my head, I would just write them out. I'll show you an example in a minute of that. So this is how I would usually solve these. This is what you would see in a lecture. And this is why it's important for you to understand that. Don't just say, oh, I do it a different way, or I was taught a different way. Nobody cares what you were taught. This is the way it works. This is the way I'm going to do it. And it's really just a shortcut for what you were taught. There's nothing wrong with what you were taught. You can do it that way if you want. It just takes a lot more time, and I don't think you get as good at algebra that way because you're kind of making things more complicated than they are, or at least you're making them look more complicated than they are, and that obscures other things that are going on when you start doing more complicated problems, and it makes them seem hard. Now, this is an example where I would write out a little bit more. Now, first of all, I need to get the two x's together on one side of the equation and the two constants on the other side of the equation. Now, I could have the x's on the right or the left. Either one's fine. But I prefer having positive coefficient on my x. The coefficient here is 13. The coefficient here is 1. So if I use the larger coefficient and move the other one, so I'm going to move the x to the left, then I'll get a positive coefficient in the result. So if I move this x to the left, this term x to the left, I get 13x minus x, which is, you subtract the exponents, gives you 12x. And then I would move this plus here, plus 83. This term to the right, it becomes minus 83. Now, doing 45 minus 83 in my head, I can do that, but it's a little bit risky, and I can more likely get it right if I actually write it out. So I'm going to write it out here. But the 13 minus 1 I don't need to write out. I know that's 12. So 12x equals 45 minus 83. When the numbers are larger like this, write them out. If you're saying, well, I'm just going to use my calculator, that's fine. Write this out first. Then use your calculator, because this is written exactly the way you'll plug it in your calculator. This is not written exactly the way you'll plug it in your calculator, so there's a good chance that you'll accidentally add the 83 over here, or you'll do 83 minus 45, or you'll do something screwy like that. So it's better to just write this down. This is the change of sign because it's the one that was moved to the other side, right? And then once you get to here, you can, if you know how to subtract that in your head, you can do that. But you can also just, at this point, it's perfectly fine to put it in your calculator and get the answer for that. But it's super, super important to write that out when it's not something really basic like the 5 and 4 I had in the previous example. And if you tend to miss this step when you do practice problems, then you know that you need to write that step out, okay? Even if they're simple numbers. So I get 12x equals 38, and then I just cross multiply. The 12 goes in the denominator on the right. And then I notice those are both even, so I'm going to have to reduce them. Right, so 2 goes into both of them, so I just divided them both by 2. In other words, I wrote this as negative 19 times 2 over 6 times 2, and the 2's cancel, if you want to think of it that way. And you can write out those steps if you want. I just noticed they're both even, so I divided that by 2, got 19, and divided that by 2, and got 6. And 19 is a prime number, so I know that that's reduced. Okay, the last thing I wanted to talk about in this little algebraic basics video series is the 3 different meanings of equals that we use commonly. This equals here, this first one here, x equals negative 38 over 12. This is part of an equation. What happened is you started with this equation up here, and you said, well, if it has a solution, then its solutions are the same as this equation, the next one down. And if that has a solution, its solution is the same as the next one down. And if that has a solution, it's the same as the next one down. And this is just telling you x is blah. So this equals is part of an equation. It means you're trying to solve for x. Now here it's pretty easy to solve for x. But remember, it started from here. So this is what we usually call an equation when you're trying to solve something for x. Okay, and you'll see this term used a lot. We'll have a quadratic equation. It'll be equals 0 usually. We solve for 0. If you have y equals x squared plus 1, that's not really an equation. So this equals here just says I'm simplifying these 2 expressions. And that's a different thing. You're saying the 2 numbers are the same, but you know what both values are, and one's just a simpler version of the other. So I'm just simplifying. And finally, this one that we had on a previous page, this is one of our rules of powers that we have to know. X to the n times x to the m equals x to the n plus m. This is true for all real numbers, unless you end up getting a 0 to the 0 power somewhere, which is bad. But for every number for which this is defined at all, this is true, and that's what we call an identity. So this equals signifies an identity. You're not trying to find a value of x that makes it true, because it's true for all values of x. Okay. So you can think of it as a rule of math. And that's what all identities you can think of as rules of math or rules of physics, things like that. It's an identity. And that's it for this series of intro videos. I hope that you learned something from it.